Okay. Now, part C, consider the curve y equals to 1 on x, sketched below with rectangles above the curve. Is this in the formula sheet? Your tan, the difference is like tan A minus B is in your formula sheet, but the tan inverse one, I don't think it is in your formula sheet. You can check down the bottom. We did provide a formula sheet in the back. So now let's consider this part C. So consider the curve y equals to 1 on x, sketched below with rectangles above the curve, approximating the area on the curve between x equals to 1 and x equals to n. The diagram is not to scale because you will see later on why. We have to prove that 1 plus half plus 1 on 3 plus 1 on 4 plus dot 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 all the way till 1 over n minus 1 is greater than ln n. Okay. Now, this is again comparing areas. Okay. What we have is on the left hand side the area. This is the area of my rectangles. If you notice, and this is so the sum of area of rectangles, and greater than the exact area under the curve. Okay. So, which is maybe I'll do the area under the curve in black, right? Something like this. And then I will do the red covering everything, okay? And then that's the sum of the rectangles, right? All the way, like probably go down here, all the way to here. Okay, so clearly the area of a rectangle is greater than the exact area under the curve. So that's the first step we figure out. Now, second step is how do we figure out the 1 plus 1 on 2 plus 1 on 3 plus 1 on 4 and so on. This is by looking at the specific locations. So we know y equals to 1 on x. When x equals to 1, y will equal to 1 on 1, so which is 1 as well, right? At this point, we know that x equals to 2, so y is going to equal to a half, right? So that's why they said the diagram is not to scale. Similarly, on 3, we know that y is equal to 1 on 3, okay? Essentially, what I have is the difference over here times the height, the base times height, right? So area of rectangles, what they should be is equal to, first of all, 2 minus 1, because we are approximating the area between x equals to 1 and x in between x equals 1 and x equals to n. The first thing, the base would be 2 minus 1 times by the height, which is 1, plus the next area, or the next rectangle's area, which is 3 minus 2 now, times by half, plus plus 4 minus 3, plus 4 minus 3 now, and then 1 on 3, and then it will be plus all the way until my n minus 1, right? This region. So n minus 1 times by the height, all right? The height over here. Going down the list, I will write this here, 1 on n minus 1, right? Because we have y equals to 1 on x. So 1 on n minus 1, that's what we have. And by simplifying, you will get that you get 1 times 1 plus 1 times a half plus 1 times 1 on 3 plus all the way onto your last term, which is again n minus 1. N and n minus 1, they only difference by 1, so 1 on n minus 1. Okay, what we get is just 1 plus half plus 1 on 3 plus 1 on n minus 1. And using the fact that the sum of the rectangle, you must write this, okay? You must write this inequality next. Sum of the area of the rectangle is greater than the exact area under the curve. So, and then we have integrate n1, 1 on x, another one. Our graph is 1 on x and then times dx, right? Finding the area under the curve. What I will get is essentially O on x and 1. It's a definite integral because we're calculating a fixed area. So what I get is O and n minus O and 1, right? And we know that O and 1 is 0. Now, some of your teachers might say to you in full unit, your LN must be absolute value. So there should be an absolute value. Okay. Your teachers might require that. My suggestion is also to keep the absolute value for your 4 units. Okay. For 3 unit, I don't think I believe it doesn't matter. But 4 unit, I think there is kind of a restriction on absolute value when after you integrate your LNs. Log to the base of e. All right. So now I know that it's just equal to ln n. Okay. But in this question, we don't have to watch out for that because they just provided a normal bracket for that. But still, right, provided that the sum of area of rectangle is greater than the exact area on the curve, we know that 1 plus, therefore 1 plus half plus 1 on 3 plus 1 on n minus 1 plus dot dot dot. Make sure you have the dot 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 in the middle. So plus dot 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 plus 1 on n minus 1, and that is greater than ln n. Okay, we have 1 proved. Now 2, does the series 1 plus half plus 1 on 3 plus 1 on 4 plus all the way until an infinite number have a limit? Give reasons. Now you will realize this is only 1 marks, okay? The reason is very simple. As n approaches to infinity, we know that ln n will also approach to infinity, okay? If you consider the ln graph, right? Ln graph is here, right? It will approach infinity, like at this point. But also, since your 1 plus 1 on 2 plus 1 on 3 plus dot 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 plus 1 on n minus 1 is greater than ln n, that means it's greater than infinity in a way, right? So therefore, the series of 1 plus half plus 1 on 3 plus 1 on 4 plus dot 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 does not have a limit, okay? Does not have a limit.